Hello everyone, welcome back to our NDT training session. In this video, we are going to explore the different methods of inducing circular magnetic fields in magnetic particle testing. These methods are crucial because they determine how effectively defects can be revealed inside a test object. Let's start our session. Methods of inducing circular magnetic field. First, we discuss about direct magnetization. In direct magnetization, the magnetizing current is passed directly through the test object itself. There are two common techniques here. First one is headshot and prod method. In this headshot method, there are two heads of the bench type machining unit. In the test object this is our test object, is placed between the two heads of a bench type magnetizing unit. A short current pulse is passed through the component. So a short pulse current is passed through the component. This is our current. The current induces a circular magnetic field around the object. This is the circular magnetic field. So these circular magnetic fields are around the object. Works best when the test object is uniform in cross section. Risk of arcing or burns if the contact is not clear. So the circular magnetic field is generated around the current path inside the material. It produces a strong and uniform magnetic field if the path is uniform in diameter. So it is well suited for bars, rods, shafts and other symmetrical parts. The next one is prod method. This is our test object. We can place two prods with handle. Two handheld prods are placed 150 to 200 mm, that means 6 to 8 inch apart on the test surface. Current flows through the prod and into the material. So the localized circular magnetic fields. The localized circular magnetic fields is created between the path. So this is the circular magnetic fields between the parts. Useful when a bench unit or central conductor is impractical. Field may be distorted depending on geometry. So detection sensitivity is reduced. The next one is indirect magnetization. In indirect magnetization, the current is not passed through the test object directly. Instead, it flows through a central conductor that the test object surrounds. In this indirect method offers two big advantages. That is, it avoids burn risk on the test object surface and it eliminates issues of poor contact resistance between heads and the path. As a result, indirect magnetization is safer and often more reliable for irregular shapes or delicate parts. This is the indirect magnetization. The next is magnetic field characteristics. First one is when current flows through a conductor or a test object, a magnetic field forms both inside and around it. The field is strongest at the surface of the conductor and its intensity decreasing with distance from the surface. This is the formation of field. The next one is line of force or 90 degree to current flow. The magnetic line of force always form 90 degree to the current flow. This creates circular lines around the conductor. The next one is right hand rule. Imagine holding the conductor in your right hand. Thumb points in the direction of current flow. Thumb is current direction. Next, the fingers shows magnetic field directions. The fingers curl around, it's showing the direction of magnetic field lines. A current in the conductor or test object produces circular magnetic field lines that wrap around it. And the next one is application notes. If the test object has no cracks, voids or flaws with no discontinuities, the circular field is uniform and difficult to detect because there is no leakage of magnetic flux. The next one is, if we use AC current for surface flaw sensitivity, combine it with wet fluorescent particles, that means suspended in liquid. This provides a high sensitivity and a clear glowing indication under the UV light. When a discontinuity is present like cracks, it disturbs the circular field. It's creating a leakage field where magnetic particles gather. This makes the defect visible under inspection. Thank you. We will see the next video.